All right, so on example 2 here, we want to try to identify extrema. We're going to use a table to graph f of x equals x cubed plus x squared minus 5x minus 2. We're going to estimate the x coordinates at which the relative maxima and relative minima occur. So if we look at the table, it's already been filled in for us, so we're given example x values ranging from -4 to 3, and our outputs go from -30 to +19. The graph does not have room for that, so we're only seeing the graph that's charting points from -3 on to +2, and that becomes 6 different data points: -5, +4, +3, -2, -5, and 0. Okay, so once you have a table in the graph of your function, you're going to estimate the locations of the extrema. So you can see that the value of f of x at x equals -2 is greater than the surrounding two values. Okay, so we are saying to look right here. Okay, there we go. To look right here and notice that that is larger than the value above it, -5, and the value below it, +3. So we assume that somewhere next to that -2 must be the maximum. It doesn't mean that the maximum necessarily is at -2, but that we would expect it to be near it. Okay, so near x equals -2. We're just estimating to get a sketch of our graph. The value of f of x at x equals 1, however, is less than the surrounding points. So -5 is less than -2, and it's less than 0, the two values on either side on our table. So we would assume that we would have a minimum near 1. It may be at 1, it may not be at 1, but we know it'll be nearer to 1 than it is to 0 or it is to 2. Okay, so at x equals 1. And then hopping on Desmos, we can double check and see if that's what we get. So I'm going to hop over there and change what you're seeing to Desmos here. Okay, and we see that we do indeed get a maximum that is near -1 and not at it. And on the other one, we get a minimum that actually is at 1. Okay, so just being able to use the table will not tell you whether the maximum or the minimum is at that value or not, but it will let you know where one should be.